Hello, everyone, and welcome back to Word Problem Wednesday. This week, as you know from hopefully working on your Go Math assignments on the website, we are talking about geometry and shapes and things like that. So a lot of this should be familiar to you or review. Maybe you've heard of some of these things before. Maybe you haven't heard of these in a while or at all. So that's why we are going over them now. So geometry, whenever you hear that word, you should always think of shapes and lines. So whenever we're talking about those, we're thinking about angles and shapes, like I said. So some words to keep in mind are point, line, ray, and line segment. So a point is just a single location in space. It's just a small little dot on something. It's just a single point. But a line is a set of points that goes on forever in both directions. So a line will always have two arrows at the end. That means that they are going on forever. This arrow, it just keeps going over, and the left arrow keeps going, and it just goes on and on and on and on and on. Okay? So a line goes on forever. Okay, it's got those arrows at the end. A ray, however, is part of a line that has an end point on one side and an arrow on the other that goes on and on and on forever and ever and ever. Okay, so a line goes in both directions, but a ray only goes in one direction. Okay, it's got a point on one side and it goes on forever in one direction. Okay, and last but not least, we have a line segment. Now I know if I say I want a segment of something, it means I want just a small piece, just cut out a small piece. So a line segment is part of a line that has a start point and an ending point on both sides. So it just stops. It's a small piece, it's a segment of a line, but it stops on both ends. So like I said before, a segment is a small piece cut out. So I cut this segment out of a line that's going on forever, but this is just a small piece. So a point is a single dot. A line goes on forever in both directions. A ray has an end point and goes in one direction. And a segment is just a small piece with two endpoints. Now, we've obviously seen shapes. We've talked about triangles and rectangles and things like that. But if you ever see the word congruent, okay, congruent is just a fancy math term. That means it's the same. A figure that has exactly the same size and shape as another. So even though these are turned in different directions, they're both still triangles and they're both the same size. Okay? Same with these rectangles over here. They're turned different ways, but they're still the exact same size and shape. So it doesn't matter how you spin it, but if it's the same size and the same shape, they are congruent or equal. They're the same. Another way to describe shapes are if they're open shapes or closed shapes, and this one's pretty self-explanatory. A closed shape means that all of the line segments are connected. So if you see over here, this trapezoid, all of the walls are connected inside, so I can't get in from the outside. It's completely closed. But an open shape is where the line segments are not all connected. I could walk around and get in the shape this way. Okay, so closed means all of them are connected. Open means that there's an opening I can get in. Another word that people use when talking about shapes is called a polygon. So a polygon is a two-dimensional, just flat, closed shape. The walls have to be closed. And it has to have 3 or more sides with angles and vertices or corners. Okay, so what that means is any of these things could be called a polygon. They're closed shapes with 3 or more sides. Okay, now if you think about, and I know some of you might be wondering, would a circle be considered a polygon? A circle is a closed shape, but you can't call it a polygon because a circle does not have specific sides or angles or corners on it because it's rounded. It doesn't have flat sides. So circle is not a polygon. Each side of a polygon has to be a straight line segment. So this shape is made up of straight lines. This one is made up of straight lines. So a polygon has to be closed. It has to have straight sides, and it has to have 3 or more sides to it. So you should be familiar with, if I say, how many sides does this picture have? You should be able to tell me that there are 3 sides. We have a side here, a side here, and a side here. Sides are the straight lines that connect to vertices, or corners. So we've got a straight line here, a straight line here, a straight line here. Those straight lines are sides. Like I was saying before, a vertex, or if you're talking about multiple, you would say they are vertices. They are the points or the corners where 2 sides meet. Okay, so we have 3 vertices or vertexes in a triangle. There are 3 points or corners where the sides connect. So a vertex is a corner, or the points. At those vertices, we have angles. Okay, and we're going to talk more about angles after this. But an angle is the space in between those 2 sides. And if you kind of take your thumb and your pointer finger right now, your thumb and pointer finger always make an angle. Okay, you can change that angle if you kind of close your fingers closer together or spread them out wide. But that spot where your thumb meets your pointer finger is an angle. Okay, it's that inside edge. Okay, and so some of you know at my desk, I keep protractors at my desk. They look like this. That's a fancy schmancy way that you can measure angles in numbers, and degrees is what they call them. But we're not going to get fancy like that. But if you've seen that on my desk at school before, that's what they use to measure angles. Okay. But angles can be different sizes, just like you can change the angle of your thumb and your pointer finger. And that's what we're going to learn about. So triangles, we know that the prefix tri means 3. So a triangle has 3 sides. It has 3 different vertices, and it has 3 angles inside those vertices, or inside each vertex. So tri has 3 of everything. A quadrilateral has 4 of everything. A quadrilateral has 4 sides, 4 angles, 4 vertices or vertexes. Okay. And they can be, those angles though can change, as we know. Okay, there's lots of different quadrilaterals in the world, but all quadrilaterals, quad means 4. So 4 sides, 4 corners, and 4 angles. So we should be familiar with these shapes on here. Use your finger right now and point out where the square is on your computer. Hopefully you are pointing to this shape right here. Point to the rectangle, please. The rectangle, we know, is a kind of a stretched out square. It's a little bit longer. Now, out of the blue and the orange quadrilaterals, which one is a rhombus? Hopefully you are pointing to the orange one at the bottom. It's like a squished square. On a rhombus, all four sides are equal or congruent, like we said before, but the angles are different, okay? And last but not least, we have a trapezoid. Other quadrilaterals we've seen are parallelograms, which is kind of like a squished rectangle. It's a longer kind of trapezoid, or excuse me, a longer rhombus, where the top and bottom are the same length and the two sides are the same lengths, but it's kind of squished. It looks like someone kind of sat on it almost. And like we said, quadrilaterals have four of everything: four sides, four angles, and four vertices or corners. Pentagons have five of everything. Hexagons have six. Hex means six. And we could go on and on and on. Octagons have eight, but they have the same amount of each item. Now, getting back to angles, okay? An angle, like we talked about, is where two rays or two sides come together at a common point in the corner, in the vertex, okay? So like we said, if your pointer finger and your thumb, they make an angle. You have your two kind of sides, two rays you're pointing, and they meet in the middle of that kind of soft spot on your hand. That's your vertex for your kind of hand angle. But as you can see, each of these angles are different sizes, and we have three different names for those different sizes. So the first one is a right angle, and it forms a perfect square, kind of L-shaped corner. And so one way that we can test this is, if you ever want to see if something is a right angle, what you can do is get the corner of a piece of paper. It can be a Post-it note, it can be a full-size paper. And if you line each of those corners on your paper are a perfect right L-shaped angle. And so you can line that up with the angle on your screen right now and prove if it lines up perfectly with the lines and the edges of your paper, it is a perfect right angle. And if you want to get extra fancy and want to use degrees and like a protractor, a right angle is 90 degrees straight up and down. So it makes a perfect L from the 0 up to the 90, or this 0 up to the 90. So a right angle is 90 degrees. An acute angle is smaller than a right angle. It is a little bit skinnier and just smaller. And I always remember, if something is mini-sized, it's always so cute. Anything like a baby-sized something, it's just so cute and little. So I always remember acute means smaller. So if you take your fingers right now, your thumb and your pointer finger, I want you to show me an L-shaped right angle, and then kind of pinch it smaller, and that is an acute angle. Anything smaller than that L-shaped angle is acute. So we have a right angle that's a perfect L. We have an acute angle that's smaller and cute. And then we have the obtuse angle, which is larger and wider. So take your thumb and pointer finger and spread them out wide as you can. That is an obtuse angle. It is larger than that perfect L shape. So right is perfect L, acute is little, and obtuse is wide. Just like I was saying, a right angle forms a perfect L-shaped square corner. You can use the corner of a piece of paper to prove it. Anything smaller than that is acute and little, And anything larger than a right angle is obtuse. Okay, math rocks. So what I want to show you right now, the last thing in our video, is you guys love the vocabulary videos we watch in class. So I have one here about shapes and angles. Hopefully you can hear it okay.
My mom told me to get in shape, so I climbed up into a triangle. My dad said he's out of shape. He looks a little bit like a rhombus. Yeah, shapes in the place. Got some shapes in the face. We got the shapes in the place.
Let's say one line is riding along, going straight as lines like to do. He meets up with his friend Hansel, and where they meet, they form an angle. Angles are measured in degrees. Spin all the way around, that's 360. If you take a right turn, that's 90. So a right angle has 90 degrees. A right angle, that's what you get in a square. You might even find it in a triangle. If it's less than 90 degrees, it's acute. If it's more than 90 degrees, it's obtuse. If it's less than 90, it's acute. I said if it's more than 90, it's obtuse. If it's 90, then it's right. You know it's nice, and yeah, it's right. Oh, we've got some shapes coming all up into place. You know, yeah, I know. So get ready for the next episode. Oh, we've got some shapes coming all up into place. You know, yeah, I know. So get ready for the next episode. A square is a four-sided shape with 4 right angles and 4 equal sides. So you can spin it like a top, and when it stops, it's gonna look the same. A rectangle is a four-sided shape with 4 right angles. So a square is a kind of rectangle, but not all rectangles are square. Is that clear? A parallelogram is a four-sided shape with 2 pairs of parallel sides. So a square, yes. A rectangle, yes. A rhombus, yes. Those are all parallelograms. A rhombus is a four-sided shape where every side is the same length. So a square is a kind of rhombus. So is a diamond. I'll keep rhyming. A trapezoid is a four-sided shape with 1 pair of parallel sides. So it looks kind of funny just sitting there. A trapezoid is definitely not a square. Oh, we've got some shapes coming all up into place. You know, yeah, I know. So get ready for the next episode. Oh, we've got some shapes coming all up into place. You know, yeah, I know. So get ready for the next episode.
All right, hopefully you enjoyed that, and you can definitely watch it again. I know you guys love to watch it usually a second time and sing along with it. You are more than welcome to. The last couple things I want to talk about real quick is something that they kept showing in this video. I don't want it to sing again, but I do want to point out, so if we look here, they drew little boxes in the corners of the rectangle, and they did that for a couple shapes as well. If you ever see a box in an angle like that, they are trying to automatically tell you that that is a right L-shaped perfect angle. Okay, so if you ever see the box, sometimes it's not there and you need to double check. But if you ever see a box drawn in an angle, they are telling you that it is right. Okay, let me see if I can find that one more time. There we go. So they were telling you here, we've got 1, 2, 3, 4 perfect L-shaped right angles because they drew those boxes for you. So the questions I have for you to answer for Word Problem Wednesday aren't the crazy long word problems this time, but you'll see below once you minimize your video that there are just some questions asking you to count the certain kinds of angles in the shapes. So it might ask you how many right angles are in this shape, how many acute angles are in this shape. So you need to remember, if it's a perfect L, it's right. If it's smaller than that, it's cute and little, it's acute. And if it's wider than an L-shaped right angle, it is obtuse, okay? Hopefully you enjoyed this geometry. We're going to continue to talk a little bit more about shapes next week, and have a great day. Bye, guys.